Hi there, welcome. This is Chris Pike. I'm the Director of NIR Products, and this webinar I'm going to be discussing inline moisture and oil measurement, primarily in snack foods, and I will be discussing installation locations and installation recommendations. As I said, I'm the director of NIR Products. I'm based at the head office of KPM in Westborough, just south of Boston in the USA. Let's begin. So when we talk about measuring moisture and oil in food, and as I said, I'm going to be primarily talking about snack food because that's typically the market that the NIR instruments are sold to. So first of all, let's talk about moisture. The number one factor for consumers of snacked and baked goods is basically flavor, the taste of the product that ultimately is manufactured. So this is one of the most important parameters in the finished product. Just give an example here, low-fat product formulations, they tend to hold more moisture than their full-fat equivalent. So it's very important to be able to control that moisture and actually measure it. Texture. It's expected that when you bite into a potato chip, for instance, or a cracker, you expect it to be crispy. So if you got something that's too wet, then you can essentially create a soggy product. Too much moisture can cause dryness, and it can actually burn the product as part of the process, creating waste. Shelf life. We expect our products to have a sell-by date printed on them, and they're expected to stay fresh up until that date. So too much moisture, there's a chance of mold and bacteria growth. So again, this is an important parameter why we need to measure moisture. Economics. A lot of times product is sold by weight. If excessively dry, then there's an increased quantity of product leading to waste. So again, good to control. Oil and fat, consistent quality. If the oil content is too high, then products can taste greasy. For baked products like crackers, oil can be used to enhance flavor, and seasonings are sometimes added as additional flavorings. We can actually measure that with our instrumentation. So by measuring this, we can actually control the consistency and ultimately reduce costs and expensive seasoning costs. Energy consumption. The final oil content in the snack is directly related to the oil fryer temperatures. So if we're able to control the or measure the oil content, then we can minimize the actual cost of energy. And finally, acrylamide. This has been classified as a potentially harmful substance. It's essentially formed in food that has been fried or baked at high temperatures, particularly in starchy products like potato chips. Accurately controlling the oil content in the final product as well as moisture will mitigate this formation. So this is a industry buzzword, so it's important that we're able to control. So when we talk about moisture, let's talk about the current methods of which we can measure moisture. So let's start by talking about moisture balancers. These are good primary methods which can be used to calibrate our NIR instruments. The unfortunate thing about them, they can be slow. They are dependent on moisture content. So if it's got a high moisture content, then you could be looking at tens of minutes just to make a measurement. If it's low moisture content, you could be looking less than 10 minutes. Typically, the product's ground, and it's a small quantity of product. So is that truly representative of your process? Sample prep is important. You need to spread the sample evenly across the platen surface to make sure that it dries consistently. And sometimes I have seen customers that have multiple moisture balances, so they take an average of multiple readings as a result of the things I mentioned up above. Convection oven. This is another good primary method for calibrating the near infrared instruments. It uses a much larger sample size. It can become more representative of the process moisture. Unfortunately, with a larger sample size comes a longer test time. And I want to make everyone aware that within the KPM offering, we actually offer a automatic temperature regulated oven, which has up to 10 compartments, so you can do multiple samples. Another good primary method is a vacuum oven. This is a much longer test, very accurate, but unfortunately, it's not something that you can use to control a process. And then finally, we got the NIR benchtops. These are two offerings that KPM have. You have the Unity SpectraStar, can be used inline and outline, and then you have the PSC quick check. Now let's talk about fat and oil measurement. There's a couple of methods out there. You've got solid extraction or ether extraction. It's a good primary method again for calibration. Unfortunately, it uses hazardous chemicals. A lot of larger companies will have these in centralized labs. Smaller organizations may not have one. They would do the second option, which is go to an external lab, which again is a good primary method. Fortunately, that takes time. You send off samples, you receive them back days, if not a week later, and they can be expensive for a sample. There's a mechanical method, it's called a carver press. It squeezes out the oil from the sample that's put into a hydraulic press. And again, it's operator dependent, and that can ultimately affect the accuracy. And then other measurements that are proven would be with the near infrared benchtops. They're quick. You've got the Unity SpectraStar on the left-hand side here, and then you have the quick check on the right-hand side. So now let's talk about NIR for moisture and oil. So there's two types. We have at-line and lab, which are essentially benchtops, and then you have the online. The at-line it just essentially shows you a snapshot of the process, which is still can be better than something that may take 30 minutes just to measure a moisture reading. So it's quick, could be less than 30 seconds, and there's no essential skills. You just essentially put the product in a cup or the bowl and press a button, and you get a sample reading within seconds. And it also can be used to take multiple samples from multiple lines. So you could have a centralized lab in the production floor, and people can walk along and do multiple tests, multiple lines. And it has been proven for repeatability. And NIR has been around for many, many years. And the calibrations are very strong and robust. It's been a proven technology. Now, what I'll be talking about today is going to be more about the online or inline technology. This is where we actually get real-time measurement. So now we don't have to grab samples from the production line and put them underneath the instrument. We have a real-time measurement of a sensor going back to either a centralized computer or a centralized PLC. That ultimately gives us more of a consistent product, particularly as we're real-time. And then we can actually control the process with those outputs. You can control dryers or fryers, temperatures, etc., based on the readings that it's giving. That ultimately gives you, obviously, energy reduction. And if it's fully automatic, you can set it and let it do its thing. That ultimately gives you increased production yield, and that ultimately minimizes the amount of scrap or rework that goes on. But it's very important within this process world to be talking about where we install these instruments. Let me just briefly talk about the NIR and how it works. As I mentioned, this technology has been around for many years. The process sensors brand instrumentation uses a fixed filter technology. And what that means is within the instrument itself, we have filters that are spinning in this filter wheel that are emitting certain wavelengths of the electromagnetic spectrum that excite the water molecule or the fat molecule in the product or the sample that it's looking at. And so the way we do that is we have a light source inside the instrument, and this is a simplified version of the mechanism. That's typically a halogen lamp, which has over a 15-year lifespan. So that full spectrum of light goes through this wheel, which contains filters that we decide are suitable for the application. And that filter wheel spins, and then the specific wavelengths of energy, if you're looking at the OH bond of a water molecule, the CH of a fat molecule, then that would pass through that filter wheel, hit a mirror, go down to product, and then what energy is not being absorbed would be reflected back onto a mirror, onto a detector. That detector then goes through our electronics. But meanwhile, simultaneously, internally, there's another light path which uses the same filters, except it goes directly to the detector. So now we have something that's been influenced by product and something that hasn't been influenced by product. And with the algorithms we use, we're able to correlate that to the specific moisture or oil content. These are secondary measurements. We always need to calibrate them against a primary method or some reference method, which I mentioned about earlier. Very simple to calibrate. You just essentially need to have a series of samples, ideally some at target and some above and below within specification, and maybe some outside of specification, both the moisture and the oil. And so you can have a minimum of 5 samples and present them to the instrument. And essentially using our calibration routine, most of our calibrations are linear, say 98% of them are. And so through linear regression, you can generate the slope of the intercept, and you then have a calibrated unit, at least statically. You would still need to grab a sample from the line just to do a dynamic shift to the instrument based on that primary method at your facility. So that's just a basic overview of how the technology works. And this is true for both for all the online instruments I'm going to show you. So the most important thing about this instrumentation, because we're inline, we've got quite a few things that can influence the reading. First thing we should know about NIR technology, near-infrared reflectance, is that it's a surface measurement. So we have to consider where to put this instrument. Ideally, we should be looking at the product where the surface is representative of the overall, which means it's an equilibrium. So that's important that the moisture on the outside is the same, or the oil content on the outside is the same as the inside. So it becomes difficult if that's not the case to actually do a calibration. So that's the first thing to consider. We now have some environmental conditions that affect the instrument. Radiant heat is one of them from the product. Anything above 140 Fahrenheit or 60 Celsius, you would actually require cooling. And all of our instrumentation has the ability to be cooled. So again, this is just a consideration. A statement here, the lower the product temperature at the location that you're thinking of installing the instrument, the more chance there'll be an equilibrium. So ideally below 122 Fahrenheit or 50 Celsius. One way of being able to select a good location is typically when you grab samples from the line to take to your lab. They're normally good locations that an install could be done. Sampling technique's important. We don't want open containers with that heat. If there is heat, if it's looking at moisture, then we don't want anything to volatile before it gets back to the lab. So you could get a couple of % variation in reading purely by just not sampling in sealed containers. These are instruments that are designed to look over conveyor belts of different bed depths, et cetera. And I'm going to show you some examples of that later. So ideally, the distance needs to be around 10 inches or 250 millimeters from product. So this allows for bed variation, bed depth variation. You can actually go from 6 to 16 inches. So keep that in mind when you're looking for the location. Continuous flow is the ideal scenario where we have a continuous amount of product coming past the instrument. We do have other solutions if there's not. If you have a belt that or a batch process that occasionally sees product, then we can put what we call product loss on the instrument that detects when it's seeing a conveyor belt, and then it will freeze the reading or ignore or send an output to the PLC to say there's no product, so there's no false readings. Vibration. Again, we're in process. If you have vibratory tables, we do not recommend they be installed on vibratory tables. There are electronics, you have a motor inside. So we recommend having it floor mounted. There are some external influences regarding the measurement. Sunlight does emit the full electromagnetic spectrum, so there will be NIR energy in that light. If it does hit the product underneath the sensor, then it will affect the reading. So that's something that we should consider. Most production facilities now use LED lighting, but if there's any mercury halide lighting, then this could also affect the reading. Another thing that can influence the readings is airborne particles or atomized oil. It has a final window in the instrument, either a polymer window or a sapphire. And if product gets onto that window, it will influence the reading that you're trying to measure, whether it be moisture or oil. When we talk about washing the line down, we always recommend that at least our IP67 be bagged, so to avoid high pressure hoses going up the pipe tube and potentially influencing or affecting the final window. We do have a IP69, which is full pressure wash down proof, and it's also a sanitary design, so it's good for clean in place. So in this presentation, I'm going to be talking about the MCT 460 series. And the two food grade instruments that we have, it starts with the MCT 466 SF, which is on the bottom left here. It will always come with a local display, which ideally is away from the process line. And then you have the 469 SF, which has a NEMA 4 display, and this is the sanitary design. But most of the discussions I'll be talking about will be this 466 SF. When I showed the principle of operation for the near infrared earlier, it applies to both instruments. But the main difference here is the enclosures that it's going into, so the IP rating. So let's talk about a typical baked snack line. So we've got certain parts of the process here, from mixing right the way through to packaging. And some of the typical installs that you can put these instruments would be after dough sheeting, after baking of the product, and then after coming towards packaging, where you've got finished product that's either being seasoned. I mentioned earlier, you can measure the oil content of seasoning as it's applied, whether it has seasoning in it or it's just oil, or you can measure the final moisture and fat content in the finished product. So when we talked about, so just an example, let's talk about crackers. So we've got a dough sheeter. This is a simplified drawing. So we have a flat dough. It's typically high moisture content, less than 50%. This will be entering the oven after it's been stamped out to the finished product. So why do we want to measure it here? Because when you're mixing the ingredients to make the dough, you want to make sure that the moisture content going into the oven is very consistent. If it's consistent, then you can control your speed through the ovens and your temperatures much better. You'll see on the right-hand side, we have the oven exit. So this is where the product exits the oven. It could be a continuous sheet, or sorry, a stamped product for a cracker. And on this particular instrument, this is actually a traversing system, which is our guardian. This instrument can actually scan across the width of your process line, and it can help you determine how well your oven is drying product from left, center to right. We're just showing an example here. Running too hot, you'll also get a color change, but you'll also see a moisture change within the product itself. So this gives you a more consistent product. I show a SpectraStar on the right-hand side. This can be used at line for measuring moisture in oil. It can also be used as a primary method to calibrate these instruments and validate these instruments. So there are some rules that I mentioned about earlier, and I will repeat these, but it's the same story. Sensor positioning, above product, continuous flow, is it at equilibrium, operating temperatures, and the cleaning requirements. That's for both the exit of the oven as well as for this dough sheeter. So these are the same rules that apply to a lot of our installs. Let's think of a baked chip. Here's a process whereby you've got an exit of the oven. This is going to be hot product. It won't be at equilibrium at that point, unless there's a cooling section. But when it comes out of here, you can see it goes down into a collection chute. So initially I'd be saying, no, I wouldn't want to install at the top. I wouldn't be anywhere near the chute. But I do have a bucket conveyor at the end, but that's not a continuous flow. And again, I'm using these same terminologies. I've got the individual compartments carrying product. But here I have a vibrating table. So if I just floor mount the instrument, look over the vibrating table, then I can see a continuous flow of product, and also I can grab a sample to validate the instrument. Again, the same rules apply to this location. Let me give you another example of a food product. This is a wafer made into a, it's ultimately sandwiched together. So this is like a wafer snack. So you have wafer filling, and then it's broken down. But at this particular part of the process of the wafer, you'll notice they come down as individual wafers, and they get lowered onto a conveyor belt. Now, we're almost breaking one of the rules, which is continuous flow. But as I mentioned earlier, we do have solutions for that. The solution here would be what we call the product loss. Essentially, it's a optical eye that can sense when the lead edge of the product passes, as well as when it does not, when it leaves the product. And during that period, it passes under the sensor. It will average the reading, and then it will give you a output, the average moisture content or oil content of that particular point. Then when the gap appears, it will ignore or freeze the last reading until it sees the lead edge. So this is just showing you another solution on looking at processes if there's nothing further back within the line to be able to fulfill these requirements. And again, I'm not going to go into these individual ones, but the same rules apply. So I'm going to talk about cookies. Cookies exiting an oven, or they could be crackers. Ideally, you want to measure the moisture content after the oven before if they're finally in packaging. So here was a novel solution. We used our Guardian product, which essentially, as I mentioned on the other slide, it traverses across the product belt. But the most important thing here is to find an area, again, hitting the rules of continuous flow of product, whereby you can make the measurement. We look at this production line right now, you've got individual products which are randomly headed towards the penny stacker or the stacking region. But at this particular process, they all collected at a certain point before going off to packaging. And this is where you have a continuous product flow. So this would be the ideal location to install. The unique thing about our Guardian HD product line is, again, continuous flow. If we're going from left to right, we're going to see the individual dividers, which will affect the reading. So the traversing system actually can stop at each of these lanes for a set period of time, and it can then give you a profile. As you can see here, everything's green, everything's within specification, but it would stop at each of the lanes, and it would show you if something was out of specification, so you could make changes further back down there. And the same rules apply as far as the environment, etc. Okay, so that's just an example of some baked products. Now let's show you some extruded products. This is a typical extrusion type line. You have anything from mixing through to packaging, you shape, you bake, you fry, you season, weighing, typical production line. The same instruments apply to food grade, which is stainless steel sensors. By the way, the MCT 460 here, that's our industrial application instrument, but it can be used in food. I'll explain that later. So we can actually measure in several locations, like we did in the prior example. So just prior to frying or baking, after the baking or frying, and then prior to packaging, either measuring the seasoning or the finished product moisture. So let me give you another example of installation. So we got product coming out of an oven. As you can see, they're individual sticks. These could be pretzel, could be, sorry, not pretzels, puffed products. And this is not a continuous flow. Again, same rules, we need continuous flow. So in this example, we could put some form of diverter, stainless steel, food grade Teflon, and we can actually force the product to hit the sensor location. So this is just another example of overcoming issues of not being able to get continuous flow. The same environmental conditions apply also. So let's think of another example. We've got a perforated belt dryer. So it's a fully enclosed oven. Typically they have multiple zones. This could be a puff cereal, a pellet, extruded pellet. So here you have the exit of the oven, whereby the perforated belt essentially continues back to the start of the process, but it dumps typically onto a conveyor belt, which may not have continuous flow. But in this example, just before it was being put onto a conveyor belt, you could actually look directly at the final cooling zone within the perforated belt dryer. The problem we had in this location is that the Vortec cooling was definitely required because there was still a little bit excessive heat, but also you would need the compressed air for the light tube, which stops any contaminants, those airborne contaminants. In this type of example would be dust from the product itself. And you've got to abide by the rules of the distance from sensor. Okay, so that's just another example. And another example of install would be, I'm calling it potato chip. It could be any particular type of vegetable that's fried into a snack, plantain, parsnip, any type of vegetable that's being turned into a chip. So you can make the measurement depending on the moisture content prior to baking or frying, after the frying, and then again, like in the prior example, before the final packaging, where you could control either the seasoning or look at the seasoning content. Why would you want to measure the seasoning? Because sometimes the sprayers in the drum can also get blocked, and you may not be able to, you may not know that until it's too late. So that's why we can measure if it's an oil-based seasoning, the oil content in the seasoning itself. Again, the same types of instruments we'll be talking about here. move on. So I'm just going to show you here an example. We're talking potato chips. We got Kettle and continuous friolators. In Kettle chips, they normally come out in a batch process. This is just simulating that you start off with a small amount of product. It's actually going from left to right. It would have occurred at the start of the kettle being put onto this conveyor belt where you start with a small amount of product. So what I'm simulating here is essentially the distance. You're going to get bed depth variation. Again, we want to be about 10 inches away from product, so we can account for that small amount of product at the start and then the higher amount of product that's during the process. On a continuous fryolator, then it's typically coming out in one particular flow. Okay. Again, the same rules apply for the environment. So this again is just another example. Okay, so I was talking about products. Now let's go back a stage. Let's talk about the ingredients that go in to our processes and how our suppliers and how the snack food producer, the bakery, uses those ingredients. They may want to measure the moisture. If there is fat content in the product, then you may want to control it or measure it prior to being processed. So the supplier itself will utilize this type of technology to be able to provide a consistent product. So always prior to packaging. And I will show you some solutions or some install solutions that they could utilize or they would utilize. And then when you receive the product, prior to it going to production, you may want to do a final check to make sure it's within specification. So here's an example of a way of conveying product. So if you've got raw ingredients coming in, you may have some form of auger or screw conveyor. And if that is the case, we have the ability to make that measurement. The ideal locations for this type of measurement would be either looking down on the screw itself. If there's sufficient product within the screw conveyor, then there's no need to remove any screw flight because product will typically bunch up onto one side of the screw conveyor, and you can then see the product continuous. Again, that continuous flow. If there's not enough product, then mechanically you would have to remove a flight of the screw just to bunch product up within this zone so it can be then pushed forward. And then finally, on the second position, you would be looking at the exit of the screw conveyor. In both of these scenarios, typically it's dried product or dry product, you would definitely need to have some form of air purge to stop the contaminant on the final window. Another solution for ingredients is looking through a window. If you had a chute, here we have a bin or chute that's putting product either into a screw conveyor or into some form of silo. You can actually look through a window, typically it would be a sapphire window, into product that is being accumulated in this chute. Now we need to ensure that there's constant product that's within this chute, and we have to ensure that it's constantly passing the window. We're unable with this solution to be able to measure free-falling particles like we have up at this point. We do have a solution for that, but at this particular location, this would be the ideal. And one of the most important things with near-infrared reflectance is you don't want to see your own reflection if you're looking at a shiny surface or a window. So you have to angle the instrument around 18 degrees. It's called specular reflection. What will happen is you actually don't get a good reading for that location. And finally, we have, for that free-falling product, we do have a solution for it. So this is what we call the snorkel sampler. You'll see on the right-hand side, the accessory is being removed from the instrument, but essentially that tube attaches to the instrument itself, the sensor itself. This is the 466 SF. And then the light beam will go down this tube, and there's a window at this particular location angled, so there's no specular reflection. And we can then measure the product that's inside this cup as it pre-falls into this. Now, the neat thing about this solution is within the instrument itself, there's a cycle time of the ability to expel the product from the cup itself. So we have a fill time, we have a measure time, and then we have a purge time, and then it cycles again. So it's not really continuous, but it's still less than 30 seconds to get a good measurement. This uses process air. We have a solenoid box that essentially drives the air down this tube. And there's purge holes that are inside the cup that expels the product. Very important is typically in this type of location, you'd be looking at low moisture content, anything below around 5% or less, because anything too wet, it will stick to that window and you will not expel, and you would end up having to remove the system. You have to support the instrument itself on a bracket. You can't just hang it. You see that here, it's actually on a support on the left-hand side. And so that you can clean the process, this is actually what's called a welding spud. And there's a sanitary clamp you'll see here that clamps onto the snorkel itself. If you undo the sanitary clamp, you can withdraw the snorkel, and then you could actually put a blank over to replace where the snorkel was, so no product will want to come out. This is just an example of where you could use a non-food grade instrument in a process that is conveying a food product. The snorkel itself is stainless, but outside of the process did not need to become a food grade instrument based on the customer's requirements. So hopefully that educated you a bit on recommendations as far as installation of this type of equipment. And at this point, I believe I may have gone a little bit over time, but no, I'm still plenty of time. So if anyone has any questions, I'd be happy to answer them. This is being recorded, by the way, and anything that's I don't get to, I can get back to you because we'll have a full list. Siddharth. I think you had your hand up, Siddharth. You can also put in the Q&A section any questions that you have. Okay, Oscar, daily wipe down. So if you've looked at the environment, looked at the dust, then you would, if you've taken that into account before doing an install, that like the air purge for the final window, then you don't typically need to check on a daily basis. As far as the instrument itself, that becomes down to the sanitary requirements on the location you're at, or the customer that you're at. Okay, so Siddharth, when we talk about oil measurement, it's a simultaneous measurement that can be similar. I mean, moisture is one of the critical, that's normally the most important parameter. I mean, oil content, unless you can control the oil content. As I mentioned, oil, when you're talking about fried products, if the oil temperature in the fryer increases, your moisture content goes down. If it decreases, your moisture content goes up. So there's an interconnection between the two. So in that type of process, yes, you want to measure the moisture, the oil content. as well. Okay, the temperature of the food. So the temperature of the food does affect the moisture content. I talked about being able to choose a location where the product is at equilibrium. I'm an instantaneous measurement. So once it passes this instrument, it will start to lose more moisture. But at that particular location, you want to be able to know exactly what that moisture content is. So the higher the temperature, the quicker the moisture content is lost, which is why ideally you want to be at a location where the lower the temperature is. Do we need product loss sensors for cookies along the scanning frame? No. That example I showed you, they weren't discrete products. It was actually going towards packaging as a continuous line of product. There is also penny stackers that stack the product up, which is another location you can make that measurement where there's a continuous flow. Again, continuous flow locations within the process is ideal. How often do we calibrate the sensors? So we recommend between 10 to 12 months you recalibrate unless the formulation has changed. You can validate an instrument by taking grab samples from the line and just check the instrument's reading versus the primary methods we discussed. But take into account those environmental conditions like a dirty window. If you're going to do any calibration, you've got to make sure that that final window is not influencing the readings that you're taking. So yes, between 10 to 12 months, we recommend. Easy routine to disassemble the accessories. I mean, all our accessories, the way we've designed this 7th generation of instrument is to make it very easy for the customer to be able to disassemble. Vortec air coolers are just essentially screwed into the back of the base of the instrument, which is the cooling panel. So that's easy to replace. There's 4 bolts holding a snorkel sampler onto the light tube. So we try and make them as easy as possible to disassemble. Okay, for bait crackers, unity control. When okay, so with these instruments, I didn't go into the outputs of the instruments, but we're able to give you any digital communication protocol that goes into most PLCs, whether it be Ethernet IP, Profinet, DeviceNet, and that will give you your live readings plus sensor parameters and diagnostics. So you can actually do some form of closed loop control based on that reading. We also do 4 to 20 milliamp outputs too that you can take in as just a raw reading. But we do not do the integration. We do not do the, we can only give you examples. We can give you all the documentation, the lookup tables, et cetera, that the instrument sends out as a reading so that you can integrate it into your PLC. And then you can do some form of feed forward or feed backwards. So on a tortilla line, chips are touching the sensor when the bed depth gets too high, should the sensor be raised? So yeah, that's why when the optics were designed on this instrumentation, it's anywhere from 6 to 16 inches from the flat underside where the beam leaves the instrument. That's typically the range of which the instrument will see it. If ever it touches that light tube, yes, you would definitely have to raise the instrument. But ensure you're no further away than 16 inches from product. If there is that much variation in bed depth, then you ideally try and look for somewhere that has a better bed depth control. That would be my recommendation. So oil vapors accumulating on the lens will affect, I just want to correct you on the word lens. It's actually a window. All the lenses are actually inside the instrument. You can clean these windows with Windex or a alcohol if there's oil residue. So just wanted to make that clear. So will it affect the moisture measurement? It's a good question, because when oil deposits itself onto the window, it typically will pick up particles that are in the process as well, and it normally sticks to the oil deposited on the window. And typically those particles will have moisture in them, and depending on the temperature in the environment, those particles could dry out, and that will be then part of the measurement for the moisture. So again, it's interesting. It's important to focus on the covering the environmental conditions. What is the life of an NIR filter? Okay, so these filters, if the temperature is not excessive, if you haven't taken into account of cooling an instrument, because you need to make sure the electronics, et cetera, are happy. But the filters themselves, we have used the same technology. As I mentioned, I've been doing this for 17 years, and filters has never been a discussion point outside of someone that may have installed it in an excessively hot environment. But typically other things fail before it gets to that point. But no, there's nothing to be concerned about with the filters. Can we get a copy of this presentation? Yes, I believe that there will be a video at the end. So is it mandatory to dismantle the instruments and clean in place? So I mentioned bagging the instrument. It's not mandatory to disassemble, but one thing I would say is that on both of those instruments, they did have interconnecting cables and local displays. If you take out or disconnect the interconnecting cable to the local display, then you will lose its IP rating. And that will be a direct point of entry into the instrument itself. So it's important to keep the two connected continuously. Power down, obviously, when you're bagging the instruments, but yeah, you do not want to disconnect those cables, otherwise your IP rating will be lost. Instrument measure, water vapor. Okay, so if you've got steam or water vapor, that steam actually and water vapor is actually measured in a different part of the spectrum. So we have a specific part of the electromagnetic spectrum that measures moisture in solids. But when it comes to water vapor, that is actually absorbed outside of the range that we're actually measuring for moisture in solids. But bigger concern with moisture with water vapor is making sure that there's no condensation building up on the final window. So that's a consideration when you're putting the install. Okay, can we measure protein? So protein has been measured. Typically with protein though, unless you can or present to the sensor a wide enough range of protein samples, it's difficult to calibrate. You have to be, as I mentioned, for example, with moisture, you have to have the range, a wide enough range. And if you can't supply that range, then it would be difficult to calibrate. Yes, we have done protein measurement. There's only a limited amount of filters that we can put in our instrument. So we have historically done moisture, fat, and protein. What I was describing today, though, was measurements that could be controlled in the process. When we talk about NIR inline, normally we're trying to control a process. If you have the ability to control protein, then yes, you could use that. But if it was just for a QC test, then typically inline NIR is used for control, as I mentioned. As far as the range is concerned, it depends on the ingredient. It depends on what material that you're looking at. If it's milk powders, it can be significantly high. If it's flour, etc. It's again, it's product dependent. Every instrument, the software. Every instrument comes with a free version of software. Anything that's purchased, it basically simulates a local display. It also has logging capability. But again, we're in process. If you want to connect all the data, we can give you the digital communication protocols to put it into your PCS or your historian, so you can log as much data as you want from the instruments. The PC software does have diagnostics routine, the free version, but it simulates exactly the same that's in the local display. So typically the software is used to log data. If you were looking at one of the bench tops, if it was the process sensors benchtop, then yes, you could connect to it and log each of the data points of each of the tests, even with the free software. How does the environment affect the equipment or reading? Temperature, humidity. So again, it's the environment that kills an instrument. Temperature, got to be in a location. If you can't find a location that's cool enough, you've got to cool it down. You've got to make those electronics happy. We can withstand up to 80 degrees Celsius ambient, typically up to 60 degrees Celsius ambient without cooling on these instruments. But you've got to make sure that the electronics are happy inside, and every unit has a cooling panel on the base of the sensor that you can attach a Vortec cooler. In the past, people used to use chilled water, but I very rarely see that anymore. Most people now use process air. And if you have that PLC communications and you don't want to waste air because air is expensive, you can actually monitor the internal temperature of the instrument, and you could put an inline valve that will turn on the air if it exceeds a certain temperature. So you actually save money because the maintenance on air compressors, et cetera, is expensive. Yes, someone else on the power as accessory if moisture is less than 10%. So I mentioned ideally less than 5%. It all depends on the consistency of the product that's going in the cup. Will it stick to that window? There's only so much air that you can push down the tubes goes into that cup. So it all comes down to whatever product, the appearance of the product. So if it does readily want to stick to windows because of its makeup, then regardless of moisture, then yeah, it may not be the best solution. You might have to look at a window install or some other location in the process. It's very product specific, but I mentioned below 5% ideally. Someone asked, MCT 460 series for measuring fat content. Yes, absolutely. The whole 460 series, they can all measure fat and oil simultaneously with moisture as well. Does anyone else have any other questions? Someone's got a question regarding the Unity. So with the difference between NIR and Unity calibrations, the NIR calibrations are typically based on thousands of samples globally, which is why they can cost higher than a Unity calibration, which may not have the thousands of samples, the robustness that the NIR calibration has. That's the benefit of going through an NIR, is it's based on a very robust set of samples that is continually being added to. But the Unity calibrations are also just as strong. So don't feel that they're inferior. Anything else? Any question? Okay, we're almost at our time. So I appreciate everyone's attendance, and hopefully this was useful, and we will pass on video. Thanks very much.